All right, good morning, everybody. Welcome to Wales Darby webinar for the fall of 2023. This is our second webinar today, Take-O Live Fire, Old to New. My name is Jim DePalma. Running the board is Christiane Levine, who's always making sure we're on task. Rob Clemens will be running questions. Please type in your questions for Rob. And I also have our Director of Infrastructure, didn't want me to tell you, he's here, Vince Benino, because all this equipment that we have that runs this stuff, we get it from Vince. We make sure it's always up and running, so thank you, Vince. All right, so first things first, let's make sure everybody can hear us. So please, if you wouldn't mind typing in, so Chris and Rob can see that, yes, you can hear what we're saying today. So let us know. I want to make sure I'm just not talking and nobody is hearing us today. All right. Also, up in the left-hand corner of your screen, you will see your
Good to go, Jimmy.
You go to webinar panel where you can make the screen bigger, smaller, whatever. You'll also see that we have a download for you today, which should be the PDF of the Take-O catalog. All right, because this is a Take-O-centric webinar today. We're talking about old to new. We're going to be talking about near boiler piping. We're going to be talking about the ECM circulators. Now, we have done all of this stuff before in some way, shape, or form in previous webinars. But today we'll be able to actually show you amp draw, GPM changes when we use these ECM circulators in a live situation, which is kind of exciting. So that's our goal for today. We're going to talk about near boiler piping. So if you've done our webinars before, you should be able to play along. If not, I will give you some quick review as to how and why we did what we did and comparing old to new, and have a surprise for you near the end. All right. Okay. All right, Robbie, all set? All right, Robbie is set. Chris is set.
Okay, here we go. So we have this live fire display. One of the things that we've been trying to do for this webinar season is have more live interaction webinars. So this is not going to be any PowerPoint. This is just live stuff. So you're going to see it happening as we switch things on and off. So we have two different scenarios here. We have a typical cast iron piping setup here with a 3-zone system and with a zone of radiant. And then we have another scenario where we would be switching over to a condensing boiler system, and there I would have a low loss header or closely spaced teeth. So quick review on piping to make sure everybody's up to speed and understands what we're talking about. So this is a dual-sided display. So on the other side of the display is where the expansion tank is. So if you're looking near the bottom, thank you, Chris, and you can see where our feed valve, our pressure reducing valve is, and the backflow preventer is. That normally would be also underneath there where you'd see the expansion valve. It is here, because this is a live unit, it's filled with water. This is on the other side of the display. You're seeing the supply piping here, all the return piping is within the display, right? We just can't, get all this stuff on one side. So my incoming is coming through here. My incoming water is coming in. This is where I'm going to set my system pressure. This is the Take-O 3450, which has got the combination backflow and pressure reducing valve in here. The fast fill feature is built into this. We can take this from 5 PSI to 50 PSI. And we're also connected to our air separator. So if you've been to any of our other webinars in the past, you know that when we use an air scoop, we need at least 18 inches of straight pipe in front of that air scoop in order for that air scoop to work. With an air separator, we don't have to worry about that, and this will scrub out the air bubbles even as we are filling the system. You see the design here, it's a cone shape on the top, as opposed to my competitors that do go straight up with a round shape and flat to the top. The cone shape is on purpose, so this is an air chamber, so we are never filled with water here. That does prevent a lot of leakage, so we don't see that on our side. We also have a shut-off valve built right into this. So once you've purged your system, if you choose to shut it off, you can shut it off, and you'll be
Go.
So this would be my point of no pressure change. So as you follow the piping up, this would be our system circulator. So we are pumping away from our expansion tank. So if you recall from previous TACO or Wales Darby webinars, pumping away, that means the circulator is going to be adding positive pressure to our system. It's going to work to your advantage. So if I had 12 PSI on this side, I'll see 12 PSI here because this is my suction side, but my positive pressure will be up here. And let's say for argument's sake, it's an additional 4. I'll have 16 PSI here. That means my air bubbles in solution get squeezed down and easily dispersed from the system from our 4900 air separator. Okay? Now, if you recall from previous webinars when we talked about pipe sizing, and this is in the TACO catalog, I believe it's on page 57, this is 1-inch pipe. So the potential on the 20-degree delta T system is 8 GPM. I know the TACO catalog says 9. We're more comfortable saying 8 because that's going to make sure that we're staying within 4 feet per second so we don't create any velocity noise. So with the potential of 8 GPM going out to these 3 zones, if I take my universal hydronics formula, which we have written on the board, and instead of dividing by my delta T times 500, which in this situation is going to be 20. So instead of dividing a BTU by 10,000, I'm going to take the GPM and multiply it by 10,000. So since I have the potential of 8 GPM through the piping, this should be an 80,000, at least up to an 80,000 BTU system. All right, so if you recall using those formulas, looking at pipe size, I can determine the potential BTUs of this system. So without even looking at the boiler, I should have an idea of what this system can produce. We are using 3/4 piping here going out to our zones. The potential through that piping, if you do recall, was 4 GPM. All right, again, making sure we're not going over 4 feet per second. So using the universal hydronics formula in reverse, that would be the potential of 40,000 BTUs here at each loop. We do not have 40,000 on this job because I can measure the GPM here, and we'll show you that as we're running the system. So I'm pumping away, I'm pulling through. This is my system circulator, and I'm going to my individual zone valves. So let's turn this guy on. So over here, we have this all wired up to our TACO ZVC panel. So our ZVC panel is going to offer you a lot of options. I can drive up to 3 circulators here, and I have them in 404s, 406s. We have them as standard panels and expandable panels. So if it's an expandable panel, we have the potential to go out to 120 zones. I really like these panels for a lot of reasons. Number one, as long as I have power brought to the panel, I really don't need an electrician to hook anything up. All right. And I can run anybody's zone valves on here, whether they're 2-wire, that would be like 2-wire actuators. If they're the 3-terminal, that would be the TACO 570 series, or anybody's standard 4-wire zone valves. So it could be Honeywell, it could be Erie, but here we're using our TACO zone centuries, all right? And I have them wired here at the bottom. On the top, you can use anybody's, thermostats. If they were Nest thermostats, which use a lot of power, Nest thermostats in combination with our ZVC, our ZVC zone valves, our TACO zone century zone valves, since they only power to open and only power to close, don't use power constantly, that combination works with this panel. So that can make life easier for you. The other reason why I really like these panels is right now we're powered up. So I got a green light showing here. So if there was any problems with the system, you know, the golden rule in our industry is, do I have power? And if I got my green light here, I know from this side of the system, I've got power. So now I can save myself a few steps and then figure out what's going on. I'm going to simulate some calls for heat. So I turned on one zone, and the way the panel works, when we have a call for heat, we're going to get a yellow light that's going to light up. When the zone valve completely opens, it's going to make its end switch, and then I will get a secondary red light that'll light up per zone. So now I will know that, yes, I got a call and my zone valve opened and made the end switch. So again, as a troubleshooting tool, if I saw the green light, yes, I've got power. I see a yellow light, yes, I have a call for heat. But if I don't see a red light, that is telling me my problem is at my zone valve. I haven't opened it up and made the end switch, and that's going to direct me to what I have to do to get the system up and running. So I got one zone calling, and you can see now that the system circulator came on. Lower left-hand corner here on this panel, we do have dry contacts, and that allows you to run up to 3 circulators here. So we have this circulator wired to the main pump end switch. So anything on the system that is wired to this panel, anytime anything here calls, we will close that switch and turn on that circulator. So now if I turn on the other 2 zones, you'll see those calls for heat light up. And as those zone valves open, then we will make the end switch. The Taco Zone Sentry zone valves, these are 3/4 bodies. All right, we have talked about this in the past. They have a CV rate, if they're threaded or sweat, of a 10.3, which is 10.3 GPM or 103,000 BTUs. These are the press version. They have a CV rating of 9.5. That's 9.5 GPM or 95,000 BTUs. So everybody here is opening up, and we only pull power to open up. So right now they're open and they're not pulling power anymore because inside the head is a circuit board, and on that circuit board is a capacitor that stores power. So I don't know if you were able to see it, but as we first turned these on, we could call this a cold start. This would be the first call of the season. They did flash for about, I say, 20 seconds. And that was charging up the capacitor. Once the capacitors were charged up, then the valves opened. The next call for heat, they will open up right away. The main focus of this webinar is showing you ECM product. And what we're showing you here really is ECM product's going to use less voltage, less wattage, right? Less amp draw, as will these zone valves. So in a situation like this, I'm going to pull 0.06 amps per zone valve, 1.44 watts, I believe. And I will be able to show you as I open and close these zone valves what the actual wattage is, or kW, that we're using here, and you'll be able to see the change of GPM and head as we open and close the valves. So why are we doing this? Because in our industry, we are being led to strategic electrification. And the HVAC industry, we're going to be tasked with making sure we can use the least amount of electrical power on all of our systems. So a combination of ECM circulators, these energy-saving zone valves, we can greatly reduce the amount of electricity we use, even on hydronic heating systems. As we move over here, you're going to see we have a T cut in, and we are now going to a mix valve. All right, so Taco makes the 5000 series mix valve. So since this would be a cast iron system, and this would be normally 180 degree system, I need a lower temperature going out to my radiant system. So I have to put in a mix valve. Since this would be typically a very small radiant zone, we have about 75 feet of 5/16 tubing looped inside this display. I need to drop down that temperature. I need to drop it down, probably to 100 degrees. So I have my mix valve here. So you see the piping, we hit a T, we are sending our hot side to the H port. This is the mix port. And this port here is the cold port, which would be the return from that radiant side. So the cold return coming back, or colder return coming back, mixed with the incoming hot water from the system, is what's going to give us our mix temperature here. And the circulator for the radiant is always going to be on the mix side going out. We want to pull through mix valves. We never pump into them. We would never have the pump here because that will force this open when I don't need it open, because when I sense enough temperature at the mix valve will close off this port and I'll only be circulating here. If I need more temperature, it'll slowly open up this port to let some of that higher temperature in. So that circulator always goes on the mix side out. So this circulator has to be independent from this circulator. So we have this circulator wired to an SR panel. Now I have a bunch of circulators on here, so we're using one larger SR panel. But if this was a typical job where I've got my 3 zones of space heating and I did add this radiant zone, this will be a single switching relay running this circulator. So my thermostat would come to that single switching relay. We would energize this pump when we get a call, and we'd send our end switch to our boiler. So I'm going to turn this circulator on by flipping this switch. Now you're going to see the light flash on any of our ECMs, and since we're in a constant pressure mode, you're going to see the orange light. That first flash of white you saw, if it came through on the camera, was we initially turned on and it's checking for air. There's no air in the system, so we're in normal operating mode. This is the 0015E3. This is a variable speed circulator, and we've talked about this many times, and I will vary my speed on the low setting and on the medium setting, and when I get to the high setting, then I'm at 100% speed, which would be 44 watts. As zones open and close on the low setting, I will follow 5 feet of head. It'll run along 5 feet of head out to 12 GPM, or 120,000 BTUs. So as zones open and close, it'll run along that 5 feet of head. And as it does that, it's going to lower its amp draw. Again, an energy saving feature. If we are on medium speed, we're going to follow 10 feet of head out to 8.25 GPM, which is 82,500 BTUs. And as zones open and close, we will vary our amp draw and lower our energy consumption. I will be able to show you that when we go back to this 0018E3. So since this is about 75 feet of 5/16 tubing, it's a small zone, right? This just could be a master bathroom or something like that. That should be at about 100 degrees at a half a GPM, 9 feet of head. So I would set this to the medium speed because, again, we're going to follow 10 feet of head. So now this is going to allow me, with this circulator, by the variable speed settings that I have here, to get as close as I can to the actual pump curve that I need for this project. All right? So that'll deliver better comfort, and again, I'll use less power. Robbie, you got a question?
I do. On the radiant pump, why did it need to be on the SR panel, not the ZVC?
Well, okay, because this zone may call when these zones are calling, or this zone may call when these zones are not calling. On my ZVC panel, on my dry contacts, I've got a main pump end switch that is set as a normally open switch that will close anytime anything on the panel calls. Then I have a normally open, a common, and a normally closed. So if I brought power to common, normally closed switch stays closed at all times unless I enable the domestic hot water priority. So that would mean that if anything on the panel calls and I had this circulator wired there, it would come on whether that radiant zone needs it or not. So I need it to be independent. If it was on the normally open, the only way it would come on would be if I prioritized that zone. So I don't know if I necessarily want to prioritize that zone. If I did, then I could wire it there, and when that zone called, the other space heating zones would have to wait. But if I want the ability to deliver space heating and also the radiant, then I want to put that circulator on a separate relay. so they're independent from each other. Are we good there? Anything else so far? Because I know I can be a run-on sentence, so I want to make sure I'm not just going away.
Nope, we had some audio issues earlier, but that has been resolved, so
Okay.
everything else is good to go.
Okay. All right, so that's the radiant side of the equation. So using this circulator on a lot of radiant jobs, which I happen to spec a lot, this is the circulator of choice. And if I was zoning with circulators, even on the space heating side, this is my circulator of choice because I can get as close as the GPM and head that I need at an economical price. I do have the VT2218 sitting right here. That is really more connected to the other system we have on the other side, which we'll switch cameras and show you. This guy comes with the two thermistors. This guy here will come out of the box set at a 20-degree delta, and I can change the delta to whatever I want. This guy here is going to measure actual temperature. So I have a supply sensor, I have a return sensor. So if this circulator was on this system here, as these zones open and close, it will sense that return temperature changing. All zones calling, it will sense that the return temperature is a little cooler, and it'll speed up the pump to get to that 20-degree delta. Once I've matched that, then it's going to settle at a speed, more than likely slow down, because that return temperature will be starting to get warmer and warmer, so it'll keep slowing down, slowing down, slowing down. As we satisfy zones, that return temperature is going to come back again even hotter. It will slow down even more. So this circulator here, which is what I have on my system at home, constantly creates a new pump curve. So it's matching the pump curve that I need based on the amount of zones calling. Another comfort feature and another energy saving feature. All right. The other important feature on these ZVC panels, since we are talking about energy, on the EXPs, we have the ability to plug in some export controls, or in my case, on my boiler at home, which is cast iron, a PC700. So that PC700 is allowing me to put outdoor reset on a cast iron boiler. I'm not changing water temperature because I cannot have that cast iron boiler condense. But what I am changing is the amount of runtime for the boiler. All right, we always have a joke. What's the most efficient boiler out there? Robbie, what's the most efficient boiler out there?
The one that's off.
The one that's off. So the more times I can keep the boiler off, more energy is saved, power is saved, and fuel, okay? So if I plug in the PC700 here, I may get a call for heat. The boiler is going to fire. Depending on outdoor temperature, the boiler will fire up to a limit. Now, if it's really cold outside, it'll take it up to its high limit, 180. But if it's like 45, 50 degrees outside, it'll fire it up to a point where the return temperature comes back at minimum 140. And if that is satisfied and the temperature is at 40 degrees, 50 degrees outside, maybe even 35 degrees, the control says, okay, we've got enough temperature based on that heating curve, and it'll turn off the boiler. It'll still run the circulator, but I've got enough BTUs or hot water in that kettle. So now I've satisfied all my zones, everything turns off. We get another call for heat maybe a few minutes later, and I still got enough BTUs sitting in the boiler. It'll run the circulator, and until that return water temperature gets below 140, it won't turn on the boiler. So that's another way of saving energy, because the idea again with this webinar is that total energy savings. You know, how are we doing that? And that is electrical and it is fuel. All right, so if it was natural gas or propane or even oil, if I can keep the boiler off, not only am I saving power, I am saving fuel. So that's what you see here on the cast iron side of things, okay? Down here, you're going to see this low loss header. Thank you, Chris. You're going to see this low loss header, because in the world of condensing boilers, we do have two different flow rates because my boiler could be at a 20-degree delta, a 25-degree delta, a 30-degree delta. Every manufacturer will show you in their install guide where you can set that boiler pump based on delta T, what you want to attain. And then out in my system side, I can have 10, 15, 20, 25, whatever delta I want. So what do we normally see in our territory here in the New York, New Jersey area? We're taking out cast iron boilers, we're putting in a condensing boiler. All right, a couple of things we should address, all right, is water treatment, which is something we have talked about. So if I'm going to do that, so Robbie's going to do a job, he's going to take out a pre-existing cast iron boiler in his house. He wants to pre-treat the system first. All right, we do not sell these products, but we do sell condensing boilers. We want to make sure we're protecting the boiler. So we're going to pre-treat that system first. That's either a Sentinel product or a Fernox product. And that's to clean the system. Any bad deposits, any corrosion that's in the system, we want to get it into solution. So when we come back a week or 10 days later, cut out the boiler, drain the system, all that crap comes out of the system. Because we don't want it getting into the heat exchanger of that condensing boiler, especially if it is a combi. Because the combi heat exchanger is even a smaller heat exchanger, and I don't want crap in that system. All right, so I pre-treated the system, cut it out. Now I got to repipe. So down here you're going to see the low loss header. And what that does is that is a pre-made, basically closely spaced T. So we've talked about closely spaced T's in the past in our advanced hydronic class or today's hydronics webinars classes that we've done. And I've always told you, and I learned this from Rick Mayo, Takeo, if I take my fist, put them together, my two thumbs pointing up, that is a closely spaced T. That's all I got to worry about. So a low loss header that you see on the bottom like this from Takeo is basically a pre-made closely spaced T. So if I look here down at the bottom, you'll see that on this pipe here, I have a mag dirt separator, and it's on the return side. So my flow rate from the boiler is coming this way and back. So I've got a flow rate here just for the boiler. This mag dirt separator is here to catch any debris that maybe we didn't flush out of the system and capture it here before it gets into my boiler heat exchanger. We want that on the return. I don't want it on the supply, I want it on the return. So there are other manufacturers that put the air separator and the mag dirt all in one package. Nice products. In the world of Takeo, we like to separate the two because, again, I want this on the return. I want to catch that stuff before it comes back into my boiler. So I've got a unique flow rate here just for the boiler. All right, so the boiler circulator is not going to see my system circulator, which would be on this side here. So I've got flow rate on the boiler side here. I got flow rate on the system side here. Yeah, there's some mixing, but that's not the primary use of this low loss header. It's to hydraulically separate the two systems. And this is something you need to do when you do anybody's condensing boiler. So you can either build your closely spaced T's, not a big deal, or you can buy this, and Takeo makes this low loss header. I got a valve on the bottom, so I can flush this out if I need to. And since I can capture some air, we can put a 400 series air vent on the top and help capture some air too. All right, so that is on the condensing side of things. Robbie, any questions so far?
No, good to go.
Good to go. All right, Chris, if we could enable the screen to show off this 0018E. So what we're going to do now is we're going to take you to the Bluetooth capabilities of this 0018E. The 0018E is a souped up version of this 0015E3, if you want to think about it this way. And it gives me the ability to go through different modes. I could set this pump to do different things. Constant pressure, a fixed speed, or if I'm using a system that's got thermostatic radiator valves, all right, the Danfoss valves, I can set it up for a constant circulation system here. What we have going on now is we have a constant pressure system because it's a zone valve system. And that's where we want to set it. So if we're looking here on the screen, let's see if I can get this to work. Should be on. There we go. So if I look here, you'll see that right now the system is operating just above 3 feet ahead. All right? Maybe 3.5 feet ahead, and it's operating at basically maybe 2.5 GPM. Now, as I open and close the zones, you're going to see that it's going to move across this line. Now, it's not going to move dramatically because we're not moving a lot of GPM in this system, but you'll see it change its speed. If you can see down here on your screen, over here we go, I'm showing you right now the GPM that we're moving. So we are moving 2.5 GPM. I'm overcoming just under 4 feet ahead, and I'm using 7.73 watts. That's all I'm using, 7.73 watts. And my ZVCs, they're just using a trickle of power from the capacitors that stored power earlier. So I'm not pulling any power. So my total energy consumption right here electrically is 7.73 watts. So I'm going to turn off the zone. Just give us a second here. That zone valve is going to close. So Chris, if we can go back to the other screen. So it closed. So now my GPM changed to 2.29. Now it's registered. 2.29 GPM. Still overcoming just under 4 feet ahead, but my watts changed to 7.96. All right, so the wattage went down. Going to turn off another zone. We're going to give it a few seconds. So the zone just closed. The pump just made an adjustment, all on its own. It's doing it all on its own. So now if I take a good look here, I am moving now 1.5 GPM. So this is a high head zone. So this is still at that just under 4 feet ahead. And now my wattage just dropped down to 6.44 watts. Okay? So this is what this ECM technology is all about. As zones open and close, we'll use less wattage. We will change our GPM. Overall system comfort is going to increase in a big way. And for my whole system, I should be using less power. Now, Robbie, is this a lot of money? Am I going to be able to take my wife out to the biggest restaurant in town by the energy savings that I'm getting here? No.
Maybe in 20 years.
Maybe in 20 years. Yeah, right. So a typical 4-zone, 3-zone system, it's not like you're going to be saving hundreds of dollars, but it is an energy saving feature, and this is what the industry is being led to do. So Taco's here, we're doing it now. Now down around where our office is here in Warren, New Jersey, and on the island, if they go further east, we get into some big, big houses with hydronic systems. Vince has got one of those. He'll never tell you that, but he does. And I could have, 10, 15, 20 zones. And if I got a lot of circulators running those zones, this is where I would see a huge increase or decrease in my energy consumption. That's where I really would see a lot of savings. But overall, we are trying to save energy, and this is what we're showing you here. Now, this circulator with this Bluetooth technology, I can now, if I want to, if I know the GPM and head that I want for the system, I can make changes just off of the screen of my phone. So this is connected to the app on my phone. And Chris, if you would please just click on the 3-foot line. All right, Chris, there we go. Actually, let me turn on all the zones again so that we can make a bigger difference here. So all the zones are calling. right? The GPM is going to increase as they open up. All right, they're opening up. We can hear them, you can't. So we're back up to just about, we're back up to 2.7 GPM, 7.73 watts. So Chris, if you could now click on that, that 3-foot line or a little lower, if possible, just with the mouse. Or in fact, go up. I'm sorry, go up. We're probably at the lowest we can go. Go up to where it says 6 feet ahead. Right there, please. Thank you. So what I'm doing here is we're actually dialing in where we want it to be. So I can change that. Were you able to do that, Chris? Well, I can change that, and if I did change that, you would immediately hear the circulator change its speed, and we could, dial in whatever GPM and head that we want. We seem to have a connectivity problem here today. All right, but that's what can happen. All right. We're trying something new here today, and it's live. On the phone, I would just put my finger on the screen and dial it up. We're trying to do it with a mouse. So maybe on my phone we try it. I got my team back there feverishly trying to get that to happen. It did in practice, but it's just not working today. So I can dial that in. The other cool thing about this circulator, I have the different modes. So on the box, we do explain what the different modes are. I'll get a little closer so, whoops, you can see it. Okay, so the blue zone or the blue mode is if I'm going to be doing a fixed speed. All right, so if I want a dedicated fixed speed, I can do that. The orange mode, that is the constant pressure mode, that would be what we would recommend for zone valves. The green mode would be what we would recommend if we're doing a constant circulation system, that would be with TRVs or what we know as the Danfoss valves. Those are non-electric zone valves. Those zone valves will open and close based on air temperature, but they're not connected to anything. And there is a bypass under them so we can have constant circulation. It's more the European method way of doing things. But I could use this 0018E3 in the fixed speed mode. Let's say I have a radiant system and it's not working properly, and I'm really not sure if it's being pumped properly. And it's kind of hard to see what was done. Maybe this tubing is in concrete. We have ways of guesstimating what the centers are so we can figure out loop lengths and things of that nature, but sometimes it's really hard. If I put this 0018E on the radiant side and I put it into that blue mode, I can turn the system on and the pump will go right to where it would be functioning based on that system layout. So then it would tell me what the GPM and head is. All right. So that's really a cool little diagnostic feature. All right, this is what I should be moving based on what this system is. And then I can start going into my troubleshooting to make sure that I can get that system up and running properly. All right. So another way to use that as a diagnostic feature, something that we find pretty cool. Robbie, any questions at all?
Not at the moment, no.
Not at the moment, no. Okay. All right. So old to new, we had our cast iron system, standard supply header, standard return header, high temperature. Oh, we added a small radiant loop. So we've got a dedicated single or static mix valve. So I'm always going to get one temperature out of this. Okay. Up, I switch it to condensing. So now my near boiler piping has to change to low loss header or closely spaced T's. We will see two different circulators on the system. They never see each other because they're hydraulically separated. Your condensing boiler is going to be set to a heating curve, and it will be changing its output based on outdoor air temperature. So right there, that is an energy saving feature because I am saving on fuel. All right, I don't have to fire all at 100%. You know, I may only have to fire at that much or that much, that much. Maybe we're down to maybe 25%, and maybe we're down to its lowest firing. You have learned from our previous webinars that we want to make sure that when we size our boilers, we are doing a proper heat loss, because what we're concerned about is making sure that at its lowest end, I'm still not dramatically oversized for that smallest zone. So a lot of these boilers have 5-to-1, 10-to-1, 11-to-1 turn downs. Those are steps in the amount of BTUs where it can fire. So I do want to be aware of getting my low end as tight to my system demand as possible. So even if my smallest zone calls, I want to make that low end as tight to that BTU demand as possible. So, said we had a little bit of a surprise for you. We're going to switch to the other camera. So again, this is live, so we practiced this. We're going to see what happens here. All right, can we get that? All right, so I'm going to go to the other side here. Modern technology, woo-woo. So over here, I've got a low temperature system. And what we're doing is we're using an electric boiler. And I'm using a hydronic coil that's got a fan on it. This is a residential hydronic coil. This is made by Space Pack. This is their thin wall. And very cool design here. I got my on button. I don't know if you can see, but I do have a digital display where I can set the temperature for whatever I want. I got a 007 E3 on here, variable speed. We know this. This is set to follow 10 feet of head at the 8.25 GPM. So for this small zone here, I've got an electric boiler, and you'll notice that there's no special piping. This is just one supply out, one return back, because it's not a condensing product. So I can dial in whatever temperature I want here. I do have the ability on majority of this boiler, these boiler sizes from a company called Electro, where I can set a heating curve, so it's going to outdoor reset. I do have a chamber in here with an element or two, depending on the size, and the control in here will pulse power to the element based on outdoor temperature and system demand. So here I'm using electric power as my fuel source. I'm not using any oil, gas, or propane. Yes, you can argue we are to make the electricity, but at this point, I'm using this as my fuel source, and this is outdoor resettable, and it'll change its output. Again, another energy saving feature. Since I have a hydronic coil here, I have the potential, because of a large coil and the fan blowing air across it, to have a lower temperature system. So if I have a lower temperature system, I will use less power. I can deliver that comfort in a nice quiet hydronic package. All right. And if I had multiple zones out here, this circulator is going to change its speed based on the number of zones that calling. So what we're showing here is in a very compact, just single zone situation, and we're using electricity here and a hydronic coil that you can put room by room as your delivery system. I think this is really cool. I think this is going to be a future item in the world of hydronics. So unless we come up with an alternative fuel source to natural gas or propane, an electric boiler is going to be a very, very good option going forward. All right. If I'm still in my house when my boiler has to be replaced, I am going to replace it with an electric boiler. You may be saying, well, what's the amount of wattage? What's the amp draw? What do I have to have from my home? A typical 50,000 BTU house, which would be about 2,000 square feet, that would require a 60 amp and a 30 amp breaker for 15 kW. So again, nothing crazy. Most houses are 200 amp service. So that would be something that is available there. Otherwise, they do need an electrical upgrade. But very simple, supply out and return. So there's no primary, secondary. I don't have to worry about making sure I have hydraulic separation. So we kind of are using new technology, but going back to old way of piping, if you want to think about it that way. All right. Any questions here at all, Rob?
So we have one gentleman that wants to discuss quickly how to kind of neaten up the wires, make it look nicey nice.
Neaten up the wires.
Yeah, so when doing the low voltage wiring, how to make it so that it's easily accessible, easily visible, and looks
Okay.
nice.
Well, all right. So if you go back to the other camera, I'm going to go back to the other display. Woo, woo, woo. Look what we're doing here. Okay. All right. So back to here. So this setup you see here and this setup you see here, this is what I have in my home. And basically I've got power coming in and all my T-stats get wired up here. So that typical bird's nest of wiring that you would see. And in my home, I've got some cloth wiring coming back. I got, more modern thermostat wire coming back. So, when I first had the house, that was a little scary looking. So I've cleaned that up because those wires just come to the top, and I can easily label, what rooms they are. I can label it either on the wire itself, or if I want to write it on the panel, I could do that too.
Got a label maker?
A label maker. Robbie's big on label makers, all right? You don't want to know. Anyway, on the bottom here is where I can put my zone valves. So whether I have a 2-wire, 3-wire, or 3-terminal, or 4-wire zone valves, we label 24 volts, we label end switch. So if it was your typical Honeywell, your 2 yellows are going to go to the 1-2 terminal. Each zone will have this. And then the 2 reds would go to the 3-4 terminal. So no wire nuts. So that bird's nest disappears. Out of the top here, depending on which panel I have, if it's an expandable panel, I'll have 2 end switches. So I'll have one end switch that would just go to the normal TT on the boiler. That's going to tell the boiler fire. I also would have a DHW end switch here. So if I did have the ability on that boiler to have and that boiler had a second TT just for domestic, let's make believe it was condensing and I wanted to use one of these panels, I would have that DHW end switch go to that boiler's DHW TT to tell the boiler I need you to high fire because we're making hot water. So very neat and clean wiring. The bird's nest disappears. And again, with the lights, all right, anybody can tell you what the system is doing. So give you a quick story if you've never heard it before. My son, when he was going through college, was working for an electrician. And they were doing all, high voltage stuff. Every once in a while they would do a boiler. When we changed our boiler at home, he wired it up. And he said, I've never done low voltage. I gave him a quick explanation of what goes where. And in 20 minutes, it was all wired up. So I'm looking at it this way. If I was a business owner and I'm hiring a new tech out of tech school, and his piping skills are good, all right, but his wiring skills are a little sketchy. If I'm using a product like this for either zone valves or zone pumps with the SRs, he immediately becomes an A tech because he can wire it up. As long as there's incoming power at this area that I can connect to this box, anybody can wire this up. I mean, we have Chris wiring this stuff up too when we make other working displays. She got really good at it. Right, Chris? Yeah, she's laughing. All right. What else you got there, Robbie?
Do you recommend putting the wires into a wire loom or some sort of...
That's completely up to you.
Yeah, so personally, in my opinion, I would say no. Yes, it does make it look nice. However, if you do have a wiring mistake or issue, it makes it hard to, visibly see the wires.
Yeah.
So what I would do is just run them parallel to each other. Usually, we're going to be mounting these units on a piece of plywood or something along those lines. I would run the wires parallel to each other on the board itself.
And label them. Yeah.
Staple them and label them. This way, you know exactly what's doing what's going to where, and it'll look just as nice in my opinion.
The scenario in my house is this control is actually like in this area here, on another wall right by these zone valves. So the longest wire is the BX wire, that because I'm powering my system circulator through here. That's the longest wire. All this wire here is pretty short and sweet and all labeled. So makes for a very nice install. Anything else?
No, that's it.
That's it? Okay. Wow, really? Was this a speed date? How long did we go here? Oh, almost an hour. Okay. Again, your download today was the Takeo catalog. Page 57 will show you the different pipe sizes based on GPM. It will show you the universal hydronics formula. It will show you the head loss formula that is in there. It'll also have a conversion chart of PSI to head. We have that written down here on the bottom. You really can't see it because, again, we like to use this as a teaching tool now that we have it. It'll also have a PEX pipe chart right there in the middle, so you can see the head loss per GPM per foot, because inside diameter PEX, much smaller than copper. We do have to be aware of that when we are sizing our circulators, because it is PEX pipe. We cannot go over 4 feet per second, so we really want to make sure that we size things correctly. All right, so all that information is right there in that Takeo catalog. So that Takeo catalog, besides being spec sheets for all the products you see here on the board, is also a tool to help you design your systems. If you flip further back into the catalog, we have all the pump curves in there so you could see and pick your circulators based on the information that you have decided that your system needs. And there's also wiring schematics in there for the ZVCs and SRs, and also piping diagrams for typical cast iron installs with an indirect, condensing boilers installs with either zone pumps, zone valves, and condensing boiler with indirect. Highlighting all these different parts and pieces and where they are in the system. All right, so there are people that we are working with, people from the air side that are getting more involved on the hydronic side, and those pages do help them remember, understand, and lay out their systems much better as they get into the wet side of the business. Okay? Anything? Oh, I was hoping we get more questions, so maybe we've been doing a really good job educating everybody up to this point. All right, so again, our goal today was to show you energy savings using ECM product based on old style systems, new style systems, and showing you another way of doing a typical hydronic system with not a gas-fired boiler. So that was my teaser to our next webinar, which will be on electro boilers. All right, my boys over in New York, Rick and Anthony, will be doing that webinar. Now, please remember that webinar will be on October 18th. All right, so it is not next week, it is October 18th. And then again, that'll be on electro boiler with the product overview, service and maintenance, and showing you how we can increase efficiency in a hydronic system. So if you can't get natural gas, don't want to bring in oil or propane, here's your way to do it with electro boiler. Again, October 18th, that is our next webinar. So Robbie, if we have no more questions, I thank everybody for your attention today, and we'll see you again on October 18th. Thank you very much.